Today, we are diving deep into probably the most mysterious, most misunderstood thing in the entire universe. We're talking about black holes. But, well, everything you think you know about them is probably wrong.
So let's just get this out of the way right now. The very first thing we have to do is get over the name. Black hole is, honestly, it's a terrible name. Because it's not a hole, not even close.
So, here's our game plan. First, we'll tackle the cosmic optical illusion. Then we'll get to the infamous point of no return. After that, a little field guide to monsters. Then we'll uncover their secret life as the universe's power plant, and we'll finish up with the invisible threat.
All right, first stop, the cosmic optical illusion. You know those amazing, mind-bending pictures we're getting from space telescopes? What are we actually looking at? Because I can tell you right now, it's not the black hole itself.
And this is where it gets wild. Black holes are not empty space. They're the complete opposite. They are, without a doubt, the most jam-packed, dense things anywhere in the cosmos. To really get your head around that, just try to picture this. You take our entire planet, every rock, every ocean, every single thing, and you crush it all down, smaller and smaller, until it's the size of a marble. That's the kind of insane density we're dealing with here.
Okay, moving on to section 2, the point of no return. This is the part everybody knows, right? This is what makes black holes the stuff of nightmares.
That legendary line in the sand is called the event horizon. It's the exact point where gravity just becomes an unstoppable force. Nothing gets away. Not a spaceship, not a planet, not even light itself. But here's the really weird part. It's not a surface. You can't touch it. It's more like a shadow, an invisible border that once you cross it, you're not coming back. Ever.
Now, you might be thinking, a black hole is a black hole. But oh no, that couldn't be more wrong. So let's open up our little field guide, because these cosmic monsters come in all shapes and sizes.
So the easiest way to sort them is by how big they are. You've got the teeny tiny microscopic ones, which are still just a theory. Then you have your standard stellar mass black holes, born from collapsed stars. Then we get to the big ones, supermassive black holes, like the one chilling at the center of our galaxy. And finally, you have the ultramassive ones, which are they're almost too big to even think about.
And depending on which one you meet, your end is going to be very, very different. Fall into a small stellar mass one, and the gravity change is so intense, you'd be stretched into a literal string of atoms. They actually call it spaghettification. But if you fall into a supermassive one, the edge is so big, the gravity change is more gradual. You could actually fly right past the event horizon totally fine, for a little while anyway.
The other way we classify them is by spin. There's this theoretical perfect black hole, the Schwarzschild black hole, that just sits there, not spinning. It works out on paper, but it's probably not real, because, everything in space spins. Which brings us to the ones that are actually out there, Kerr black holes. These things are spinning so fast, they literally grab onto the fabric of spacetime and twist it around with them. Yeah, every black hole we've ever found is one of these.
Okay, I hope you're ready for a serious plot twist, because this next part, this is the shocking secret of black holes. We're talking about the universe's power plant.
We always think of them as these cosmic vacuum cleaners, right? Just sucking everything in, destroying whatever gets too close. But is that all they do? Are they just destroyers?
The answer is a huge, resounding no. It turns out they aren't just takers. They give back to the universe in a massive way. They're basically cosmic batteries.
And here's how. Remember those spinning Kerr black holes? Well, right outside their event horizon, there's this weird region called the ergosphere. The black hole is spinning so fast that it's dragging spacetime with it, churning up this incredible storm of raw energy. Some think that a futuristic civilization could literally plug into this thing and power their entire galaxy.
And they're not even messy eaters. A black hole only actually consumes about 10% of the stuff that spirals into it. The other 90%, it gets blasted out into space in giant jets or converted into that pure, raw energy we were just talking about. So, we know what they are, we know the different kinds, and we know their secret power. But now, it's time for a final warning. It's time to talk about the invisible threat.
After all of that, what's the single most terrifying thing about black holes?
It's this simple. By themselves, floating in space, they are completely 100% invisible. The only reason we can ever see a black hole is because of the cosmic fireworks show happening around it.
when it's tearing apart a star or a gas cloud. That stuff gets superheated and glows brightly. But a lonely black hole, drifting through the void, it's perfectly black against a black background. You'd never see it.
And that's the ultimate terror for anyone exploring space, isn't it? You wouldn't see it. There'd be no red flashing light. The only way you'd know you were in its grip is when you looked out the window and saw the stars in front of you starting to warp and bend. And by then, it's already over.
Black holes are one of the universe's great dark secrets. It really makes you stop and look up at the night sky, at all that darkness between the stars, and just wonder, what else is hiding out there?